Welcome! Today we're going to explore a really beautiful idea, something about the very first moment of our universe. It's this incredible instant of creation that, well, it set the stage for everything we see. Let's dive in. You know, it all starts with a question, a huge cosmic mystery that really had scientists stumped for decades. Think about it. When we look out into space, no matter which direction we look, the universe looks, well, remarkably the same. The same temperature, the same physical laws, galaxies spread out in a pretty similar way. So why? So when we try to explain this using the standard Big Bang model, we actually run into a couple of really big puzzles, things that just don't quite add up. Okay, so first up, we've got what's called the horizon problem. Just picture two really distant parts of space. According to everything we know, they are so far apart that there's been no time for light or anything else to travel between them, ever. So how on earth did they end up at the exact same temperature? It's like two people who have never met or spoken showing up to a party wearing the exact same obscure outfit. It just doesn't make sense. And then there's the flatness problem. The geometry of our universe, the very fabric of space, is just incredibly flat. But here's the thing, over 13.8 billion years, even the tiniest bit of curvature at the beginning should have grown and grown, leaving us with a universe that's wildly curved, like a giant sphere or a saddle. But it's not. It's flat. It's like it's been balanced on a knife's edge for billions of years. And again, you have to ask, why? Right. So the solution that was proposed for these puzzles, it's as bizarre as it is beautiful. And it all happened in this tiny fraction of a second. An event of almost unbelievable speed. So what if we think about it this way? What if, in that very first instant, the universe didn't just expand? What if it inflated? I'm not talking about a steady growth, but something way more dramatic, a supercharged runaway expansion. And this idea, this has a name, cosmic inflation. The theory goes that for a ridiculously brief moment, the universe just expanded exponentially. It grew faster than the speed of light itself. The scale of this is, well, it's just staggering. We're talking about the universe growing by a factor of at least 10 to the power of 26. That's a 1 with 26 zeros after it. In a flash, it went from being smaller than a single atom to bigger than a galaxy. And this all happened in less time than it takes light to even cross that atom. It's almost impossible to wrap your head around. Okay, here's a way to try and picture it. Imagine you have a tiny little dot on a balloon. Now, in the blink of an eye, that balloon inflates to the size of our entire galaxy. That dot, and all the space on the balloon's surface around it, has been stretched out to an absolutely unimaginable size. That is basically what inflation did to the universe. And here's the really cool part. This one single idea, it brilliantly solves both of those cosmic puzzles we were talking about, just like that. So remember the horizon problem? How did distant regions get to be the same temperature? Well, inflation solves this perfectly, because before that crazy expansion, everything that would become our universe was packed together in a tiny space. Everything was in contact, everything could mix and settle down to the same temperature, and then, whoosh, inflation took that tiny uniform patch and stretched it out to become the enormous, uniform universe we live in today. And the flatness problem? It's just as elegantly solved. Let's go back to that balloon. If you were a tiny ant standing on the surface of that now galaxy-sized balloon, from your perspective, the surface would look completely flat, right? You wouldn't be able to see the curve. Well, that's exactly what inflation did to the universe. It stretched out any curve that might have been there until it became so enormous that it just looks flat to us. Okay, so it's a beautiful theory. It solves our problems, but is there any proof? How could we possibly know if something this wild actually happened? Well, we look for the echoes it left behind, the fingerprints of that first moment. And we find those echoes in something called the cosmic microwave background, the CMB. You can think of it as the faint afterglow of the Big Bang. It's this ancient light that fills the entire universe, and it's basically a baby picture of the cosmos, taken when it was only about 380,000 years old. Now, when we look at this baby picture of the universe, we see something amazing. The temperature is almost perfectly the same everywhere, but not quite. There are these incredibly tiny fluctuations. We're talking about differences of just 1 part in 100,000. And here's the kicker. This isn't just random static. These tiny variations are exactly what the theory of inflation predicted we would find. You know, this whole idea started back in 1979 with a physicist named Alan Guth, and others like Andre Lind helped refine it. And over time, the evidence just started to pile up. First, the COB satellite gave us the first hints, and then much more recently, the Planck mission gave us this incredibly detailed map of that ancient light, and it confirmed the predictions from inflation with just stunning accuracy. And those tiny temperature spots on that map, they're actually the imprints of something even smaller. They come from microscopic quantum jitters that existed in that first moment. Inflation took these tiny fluctuations and stretched them out across the cosmos. And those stretched out ripples, they became the seeds for everything. The seeds for all the galaxies, the stars, everything we see today. I mean, this timeline is it's mind-bending. Inflation starts and stops in this impossibly small fraction of a second. But then what? Well, when that insane expansion suddenly stopped, all of that energy had to go somewhere, right? It got converted into this super hot, dense soup of particles and radiation. They call this process reheating. And basically, that energy from inflation is what created all the matter and all the energy that fills our universe today. So this theory doesn't just explain our own universe's past. It actually points to a reality that is, well, it's truly mind-bending, something far beyond what we know. You see, some of the most popular models of inflation suggest something pretty startling. The idea is that inflation stopped here, in our little patch of the cosmos. But maybe it never stopped everywhere else. Maybe it's still going on, an eternal process of creation. And that leads us to the idea of a multiverse. In this picture, our whole universe is just one bubble in a vast cosmic ocean that is still inflating. And in this ocean, new bubble universes are constantly popping into existence. And what's really wild is that each one of those new universes could have completely different laws of physics. So this leaves us with this huge, final question, a really awe-inspiring one. Could it be that we're living in just one of countless cosmic bubbles? Is our entire universe with all of its stars and galaxies just one among many? Well, I hope you enjoyed this little journey to the very beginning of time. If it sparked your curiosity, maybe consider subscribing so we can explore more of these incredible ideas together. Thanks so much for joining me.
Like and subscribe.